Hello everyone, this is Adnan and welcome to Chemistry with Adnan. Please subscribe to the channel if you have not subscribed yet because I'm covering the entire syllabus of IGCSE Cambridge Chemistry. The course code is 0620 and so that you can keep coming back to the playlist and revise or prepare for the exams. So in this lesson, we are covering 6.3 reversible reactions and equilibrium past paper questions. So basically, we are practicing questions from the past papers. In my previous two lessons, we covered reversible reactions and equilibrium 6.3 for core students and for the supplement topics for extended students. So both the videos are, on my channel. You can, search them in the playlist. So, I would request that you should watch those videos and then come back and try to attempt these questions. So when you see this question, when you see a question, you can pause this video and try to answer it on your notebook, and then you can play and then you can compare your answers with my explanations, right? So question number one: sulfur is an element in group 6 of the periodic table. Sulfur dioxide is formed when sulfur burns in air. Sulfur dioxide reacts with oxygen in the presence of a catalyst to form sulfur trioxide. And this is a reversible reaction. Complete the equation for this reaction by writing the sign for a reversible reaction in the box. So yeah, so this is the first topic of 6.3 core, where they tell us that the sign is which looks something like this, right? So this is the symbol for a reversible reaction. Let me just draw it. Yeah, this. So I hope this is clear. And now next one is cobalt 2 chloride can be produced can be used to test for the presence of water, and state the meaning of the symbol. Yeah, again, this is another question. And here it means a reversible reaction, right? Okay, so I hope this is clear. And now we move on to the next one, question number 3. And question number 3 says that this question is about zinc and compounds of zinc chloride, blah blah blah. State the meaning of the symbol. Yeah, again, it's the same question. You can see that they keep asking the same questions. So it is very important to practice past papers. So reversible reaction. Okay, question number 4. Now, state what is meant by the term closed system. So nothing can enter or leave. A closed system, in thermodynamics, we have three types of systems. We have open systems in which, mass and energy both can be exchanged, with the environment. And then we have closed systems where mass cannot be, uh, you know, uh, exchanged with the surroundings, but energy can, right? So, and in so in isolated system, neither energy nor mass can exchange with the surroundings. So isolated systems they're insulated. So now nothing can enter or leave, not even energy. So I hope this is clear. So state what is meant by the term closed system. So here you say that nothing can enter or leave. State two characteristics of an equilibrium. So yeah, this is the question that I referred to in my previous lesson, where I explained that how they will ask you questions. So you see, this is 2 marks, and we know two characteristics of of an equilibrium. So the first one is that the rate of the forward reaction uh, equals to or equals the rate of the equals the rate of the reverse reaction. Okay, so I hope this point is clear. And the second one is the second characteristic of an equilibrium is that the concentrations, they don't change. So we write that concentrations of reactants and products are constant, or they remain the same, right? I hope this is clear. Yeah, because imagine you have two cars, and they are headed in opposite direction, right? And they have this uh, thing in front of them, so that to avoid accidents or stuff, whatever. So so this car is moving in this direction, and this car is moving is in this direction, right? So now, if their speeds are equal, so they will appear to be stopped, they will not move, right? So this is what happens in equilibrium, that if we have a forward reaction, and A plus B changing into C and D, and then C and D react back and produce A and B. So when their speeds are equal, their rates are equal, so we say that the equilibrium is at the reaction is at equilibrium, and the concentrations of the reactants and the products, they don't change, just like these cars, they don't move. So I hope this is clear. Now we move on to the next one. Complete table 4.1 to show the effect, if any, on the concentration of X at equilibrium for each change of condition. So okay, so change of condition and effect on the concentration of X at equilibrium. Okay, so temperature is, decreased. So what will happen to the concentration of X? Where is X? Okay, so they are referring to this equation, right? And we know that from delta H value that this is an exothermic reaction. So remember what I told you guys, that if a reaction is an exothermic reaction, this is an exothermic reaction, delta H is negative. So we treat temperature as a product, right? In exothermic reactions, this is an exothermic reaction. So now what is happening to the temperature? Temperature is decreased. So you see, if we decrease temperature, so it means that we are decreasing a product, right? So the reaction will shift to the right side, towards the product's side, so that more temperature can be produced, and the change is counteracted, right? Or the change is minimized. That is based on the Le Chatelier principle. So since X happens to be on the product side, and the reaction is moving towards the product side, so the concentration of X will increase. So whenever they ask you about the temperature change, so you must need to figure out that whether the reaction is an endothermic or exothermic, and then you will answer accordingly. So now concentration of HCOOH is decreased. Okay, so now we need to see, we are decreasing concentration, but we don't know that on which side this thing is, right? CHOOH, and yeah, that's it, right? It's here. So it's a reactant, and we are decreasing the concentration of this reactant, right? So we learned that decreasing a concentration of a reactant will force the reaction to shift the left side, towards the reactants side, so that more reactant can be produced, and the change is minimized, or the change is compensated. So again, if it is shifting towards the left, right, we are decreasing concentration. So, oh, okay, now the concentration of X, yeah, since the reaction is moving towards left side, so this side will increase, the product's concentration will decrease, and the concentration of the reactants will increase. So X will decrease. So I'm gonna write here, decrease. Yep, I hope this is clear. Now concentrations of both HCOOH and CH3, that's a carboxylic acid, and this one is that's methanoic acid, and this one is ethanol. Okay, anyways, so you need to look at these both these compounds, that where they are, right? So yeah, both of them, they are reactants. And what is happening? Decrease. Yeah, again the same thing. So if you decrease concentration of both the reactants, again the reaction will shift towards the left side to create more reactants, right, and to compensate the change. And in that case, again, X will decrease. So finally, if a catalyst is removed, yeah, so if a catalyst is removed, there will be no effect on the concentration of X, because a catalyst, affects the forward reaction and the reverse reaction in the same way. So the reaction doesn't shift anywhere, right? So you will write no effect. The only effect of removing a catalyst will be that X will be produced more slowly. Like for example, let's say if this reaction is achieving equilibrium with catalyst in 5 minutes. So by after removing a catalyst, so the same amount of X may be produced maybe in 10 or 20 or 30 minutes, right? So the reaction speed, the reaction rate will slow down, and for it will affect both the reactions, the forward and the reverse reaction. And equilibrium will it will take time to achieve equilibrium. So I hope this is clear. Now we move on to question number 5. The Haber process is used to manufacture ammonia. State the main core source of each gas used in the Haber process. Nitrogen, I told you guys this is a memory based question. Nitrogen, we source it from air, because we have 78% of it in air, and hydrogen is sourced from methane, because you can see that methane, it has 4 hydrogen atoms per molecule, right, as compared to 1 carbon. So ratio is 1 to 4. So we have lots of hydrogen atoms per molecule. So we use methane gas, right? So I hope this is clear. And yeah, we move on to the next one. Again, this question is about the equilibrium or Le Chatelier principle. It says that the equation for the Haber process is shown. The reaction is reversible. The forward reaction is exothermic. Yeah, we can see that because the delta H value is negative. And state what is meant by the symbol delta H. So that's enthalpy change. Enthalpy change. Yeah, that is enthalpy change. So delta H for the forward reaction is 92 kilojoules per mole. State why this value shows that the forward reaction is exothermic. Yeah, so because it is negative, right? So we know that. So delta H, value of delta H is negative. That is why value of delta H is negative. So this is why we know that the reaction is exothermic. And this is how we know that. Okay, so state the typical conditions and name the catalyst used in the Haber process. So again, memory-based question. You have to memorize this. Temperature is 450. Pressure, yeah. So you see this is kPa. So if you look at your textbook or the this student learning outcomes, so you find 2 types of units. kPa, it's 20,000, right? And if it is atm, so atm is 200 atm. So now you have to, before answering pressure question related to the Haber process, so you have to look at this, that which unit they are asking, right? So if it is ATM, then you will not write 20,000, but you will write 200. So this is very important, and this is where many students they make mistake. And catalyst, we use iron catalyst, right? So iron catalyst is used. Okay. So I hope this is clear. Now again, next question. Complete table 3.1 to show the effect, if any, when the typical conditions in the Haber process are changed. Use only the words increases, decreases, or no change. Okay. So temperature increases, effect on the rate of the forward reaction increases, yes, but the backward reaction or the reverse reaction will also increase. The effect on the concentration of ammonia at equilibrium. Okay, so now you can see that this is an exothermic reaction. It is written here, and we can see this from the enthalpy change sign. The value it is del negative, and ammonia is on the product side. So we treat temperature as a product because it is an exothermic reaction. So now temperature increases. Yeah, so if we are increasing temperature, the reaction will shift to the other side so that the heat added can be reduced. Because if forward reaction is exothermic, and the reverse reaction will be endothermic. So the reverse reaction will consume that heat, the heat that we added, and the reaction will shift towards the left side, towards the reactants, and the concentration of ammonia will decrease. So effect on the concentration of ammonia at equilibrium, it decreases. I hope this is clear. We move on to the next one. Pressure decreases. Okay, we are decreasing pressure. Effect on the rate of the forward reaction. Yeah, so now let us see. Pressure affects, when pressure is applied, the reaction shifts towards the side where we have fewer number of moles, right? So in this case, we have 4 moles on the left side, 1 mole of nitrogen, and it is reacting with 3 moles of hydrogen. You can see, so 3 plus 1, 4 moles. And on the right side, we have only 2 moles of ammonia. So on the right side, we have 2 mole. Okay, so if we increase pressure, the reaction will shift towards the fewer moles. And if we decrease pressure, then the reaction will shift towards the greater number of moles, which is the left side. Now, in the question, they are decreasing pressure. So decreasing pressure will shift the reaction towards greater number of moles, and the reaction will shift towards the left side, and the rate of the forward reaction will decrease, and the rate of ammonia will also decrease. So here we both write like both decrease and decreases, right? Okay, catalyst, no catalyst, the rate of the reaction will decrease, but effect on the concentration of ammonia at equilibrium, there it will be no change. So yeah, catalyst only decreases the rate of a reaction, but it doesn't change the concentrations or, yeah, on equilibrium or at equilibrium. I hope this is clear. Now, we move on to the next one. Explain in terms of collision theory why increasing the temperature increases the rate of the reaction. So we have answered this question in our previous session of past paper practice. This topic is related to a different chapter. So I'm not going to answer here because it is not directly related to equilibrium. So we move on to question number 6. Well, let me talk about this. Yeah. Explain in terms of collision theory why increasing the temperature increases the rate of reaction. So we know that increasing temperature increases kinetic energy, right? So kinetic energy of particles increases, which increases the, frequency of collisions, right? And increases the number of molecules with activation energy. right? Like collisions, and increases the number of molecules with energy equal to or greater than the activation energy, right? Than the activation energy. So, that is why there will be the rate of the reaction will increase. Okay, so I hope this is clear. Now we move on to this one, balance the equation. Okay, so you can pause this video and try to balance it. The mole ratios are 4, this is 11, and this is 2, and this is 8. Okay, a bit tough, but eventually you will be able to do it. But if you take more time on this, just skip this question, solve the rest, and then you come back on this, right? So you don't you won't you don't need to spend 30 minutes on balancing this equation. So name Fe2O3, include the oxidation number. So this is iron oxide and this is iron 3 oxide. Again, this has nothing to do with equilibrium. Iron 3 oxide. This is related to our next topic, which will be covered in our upcoming video. And the equation for stage 2 is shown. Okay, so explain why a temperature greater than 450 is not used. Okay, now this is a question that is related to equilibrium, right? So if we use to explain why temperature greater than 450 is not used. So this is an exothermic reaction, you see. So that is why, and we are interested in getting sulfur trioxide, and it is a product. So if we increase temperature on an exothermic reaction, it's going to shift towards the left side, and this will decrease the yield of sulfur trioxide. So you can say that since the reaction is exothermic, increasing temperature is going to, or increasing temperature will shift the reaction to the left, and or to the reactants, decreasing the yield of SO3. So I hope this is clear. Explain why a pressure lower than 2 atmospheres is not used. So again, you can see that we have greater moles of on the left side. We have 3 moles on the left, and we have 2 moles on the right side. So again, the same thing, it will, since we have, you can say that since there are fewer moles on the product's side, right? A decreasing pressure will, shift the reaction to the reactants, and decreasing the yield of SO3. So I hope this is clear. Yeah, since there are fewer moles on the product side, decreasing pressure will shift the reaction to the reactants where we have more moles, right? And the concentration of SO3 will decrease. So question number 7, write a chemical equation for the reaction occurring in stage 1. So the chemical reaction in stage 1 is sulfur is burned in the presence of oxygen, and it is converted into sulfur dioxide. You see, it's written here. The word equation is written here. Molten sulfur burns in air means oxygen. It's a combustion reaction to produce sulfur dioxide. That's it. So state the essential conditions that are necessary for stage 2 and write an equation for the chemical reaction that occurs. So this is stage 2. Sulfur dioxide reacts with oxygen. So let's write the equation first. SO2 plus O2, and that's gonna make SO3. And to balance this equation, I need to put 2 here. Yeah, and I need to put 2 here, right? So now we have 6 oxygens on both sides and 2 sulfurs on both sides, and the equation is balanced. And this is a reversible reaction, by the way. And now state, okay, so what are the other conditions? Again, it's a memory-based question. Temperature has to be 450 degrees Celsius. Pressure, it has to be 2 atmospheres, and a catalyst that we use is a vanadium 5 oxide, right? So this is how it's done. And write a chemical equation for the reaction occurring in stage 3. So now stage 3 is sulfur trioxide combines with concentrated sulfuric acid to form oleum. So sulfur trioxide, the formula is SO3, and it combines with sulfuric acid. So a sulfuric acid formula is H2SO4, and that's going to make the product oleum. The formula is given H2 S2O7, right? That's it. So name the substance that reacts with oleum in stage 4. Yeah, so oleum reacts to form concentrated sulfuric acid. So name the substance that reacts with oleum in stage 4. Okay, they didn't talk about this, so it's water. It's a memory-based question here, right? Okay, so I hope this is clear. Now we move on to question number 8. How many are remaining? Okay, we have a few. All right, so state 2 characteristics of an equilibrium. We have talked about it. The concentrations, the rate of the forward reaction and the reverse reaction will be the same, and the concentration of the reactant and the product will remain constant. This is going to give you 2 marks. We have already answered this question above, so I'm not going to write it here. Okay, they use this information to state why the manufacture is not carried out at temperatures below 300. What are they producing? Industrial process to produce ethanoic acid, high yield of ethanoic acid. The purpose of the industrial process is to produce a high yield of ethanoic acid at a high rate. So yeah, so again, it's related to collision theory. If we used lower temperature, then if you use a temperature below 300, so the rate will decrease, right? So the reaction will slow down. And above 300, so yeah, so if we increase temperature than this, so it's an exothermic reaction, so the reaction will shift to the left, and the yield of ammonia ethanoic acid will decrease. So yield of ethanoic acid too low, right? Okay, so now the next one, complete the table using only the words increases, decreases, or no change. Adding a catalyst, effect on the rate of the forward reaction, it increases it, right? So effect on the rate of reaction of a catalyst, it will increase by adding a catalyst, or it will decrease by removing a catalyst. But the effect on the equilibrium yield, it will remain the same. Remember that it will be there will be no change. Decreasing pressure, so where is the equation on which, okay, effect on the, okay, they are talking about the same thing. Effect on the rate of the forward reaction. Did they give us the balance? Yeah, this is the balanced equation. It is given. So now we have 2 moles on the left and 1 mole on the right, and decreasing pressure. So decreasing pressure will shift the reaction to the left, and the concentration of ethanoic acid will decrease. So concentration will, yeah, so the rate will decrease, it decreases, and the concentration will also, it also decreases. Okay, so suitable catalyst, remember that the transition metals are used as catalysts. So here cobalt is a transition metal. So you write just, use circle or just write cobalt. Sometimes they ask you to circle, and the reason is that it is a transition element. Well, this is not the exact reason, but you will study it in A levels. So here you just only need to know that transition elements can be used as catalysts. So why transition metals can be used and other metals cannot be used, we'll talk about this in our upcoming course of A levels. Okay, so question number 9, name the industrial process to make ammonia. Yeah, Haber process. Memory based. State the raw material from which nitrogen is obtained, air. What is meant by the symbol reversible reaction? State the temperature and pressure used in the industrial process. Memory based 450. You see it's atmospheres now, so you must write 200. Do not write 2000, 20,000. You will get 0. Name the catalyst used in this industrial process. Iron catalyst. Okay, then the forward reaction is exothermic. State the effect, if any, on the position of equilibrium. If temperature is reduced, so temperature is a product. Is if you reduce it, the reaction will shift towards the right side to make more ammonia. So, but it says state the effect, if any, on the position of equilibrium. So temperature is reduced, will shift to the right, and pressure is reduced. So if, okay, let me write the balanced equation. N2 plus 3H2 and 2NH3. Yeah, if we have more moles on the reactant side. So if pressure is reduced, so the reaction will shift towards greater moles. So it will shift to the left. Okay, so I hope this is clear. So since it has 4 marks, so you have to give the reason as well. It will shift to the right because reaction is exothermic. That's it. And the pressure, if pressure is reduced, reaction will shift to the left because a reactants has more moles. Yeah. So I hope this is clear. And yeah, yes, it is always useful to look at the marks, and it guides us that how much we should write and how much, like, our answer, how detailed our answer should be. So I hope this is clear. Now this is the like part G, explain in terms of particles what happens to the rate of reaction. I'm not answering this. This is not related to equilibrium. You have the formula of the compound. Okay, skip. Hydrated copper 2 sulfate as a, okay, is a color. Okay, yeah, like what should I do? Should I answer this? Explain in terms of particles what happens to the rate of reaction when the temperature is reduced. So the particles will lose kinetic energy, right? They will slow down, there will be less collisions, and the particles having activation energy will decrease, and that is why the rate of reaction will slow down. So give the formula of the compound formed and sulfuric acid reacts with ammonia. Okay, so the formula is, okay, let me just write the equation. NH3 plus H2SO4. So they're gonna make, yeah, ammonium sulfate, right? So this is an acid-base reaction basically. So ammonium sulfate, the formula is NH4 and SO4, right? And yeah, so I hope this is clear. And now state the term given to water molecules present in hydrated crystals, and that is called water of crystallization. Water of crystallization. State the color of hydrated copper 2 sulfate crystals. Memory based, you have to memorize, you have to remember this. It's blue. And write the formula of hydrated copper 2 sulfate. So the formula is CuSO4.5H2O, right? So I hope this is clear. If you need one-on-one tutoring lessons, you can fill out the Google form that is given in the description. And you can also join my free community on school.com with the name of High School Chemistry, where you will be able to attend free lesson once a month. And you can ask me questions, you can post questions, you can participate in the discussion forum, you can interact with other students from around the world. And yeah, and if you there's a premium package available where I offer 4 lessons in a month, once per week, and the price is very cheap. It is just for $20. So if you are interested in regular lessons with me, you can join the premium package. So this will be all for today from my side. I'll see you in the next one. Take care. Goodbye.